Welcome back again. This is principle of conservation of linear momentum, the next topic after finishing the third law. Remember, this whole chapter was like this: force, then about inertia, friction, inertia, and then first law of motion, second law of motion, third law of motion, and after many practical applications, some numericals, you are now in the almost in the last topic. This is principle of conservation of linear momentum. What is the meaning of conservation? Conservation means something is remaining same, not changing. Okay, conservation means it will not change by its own. So here there is a rule. Principle means there is a rule which says linear momentum. You remember there was P equal to mass into velocity. After doing the second law, we used it. P is equal to mv. That momentum will remain conserved, not change. There is a rule like that. So that we will try to study. Okay. Let's start the situation. Let us make the situation. In physics, to understand, we make situations. Okay. We imagine a situation. Let that be happen. Then in that situation, what will happen? Okay. What is the statement? For a system which is not under the action of external applied force, meaning that if there is no force applied, what will happen? The linear momentum means the P, linear momentum, is constant, remains same. Okay, that is the meaning, right? Now we'll try to write what is that and how to arrive at that situation mathematically, how to make it a true thing. So how to start? We already know first law, second law, and third law, so we are going to use that. Okay, from second law of motion. Second law of motion, rate of, if you remember, change of momentum is proportional to applied force. This we already know. Meaning is what? P2 final, P1 minus, we already did this. Okay, you see, visit the previous classes, you will know this. This was already there. This was already, this is second law, of course. Okay, rate of change in momentum divided by time means rate of change. Now here you can understand P1 is the initial momentum, P2 is the final momentum, T is time, and F is the applied force. You can write it here, where what we have used, P1 is momentum at t equal to 0, P2 is momentum at time equal to 0, time equal to 2. Okay, T is the time, F is the applied force. Okay, I'll not write what is applied force is here. If you write, it will be understood. Okay, now after that, when, or if also you write, when F is equal to 0. Why I write this? Because which is not under the action of external force. We want a system where there is no force, not under the action of external force means we want to create a situation when there is no force. That means F is 0. Let us see what the second law of motion makes out. Okay, what it is giving out when this becomes 0, in order to see whether it is true or not. When F is equal to 0, what will happen? P2 minus P1 by T equal to 0. You cross multiply it, P2 minus P1 equal to 0, T zeros are 0, so this will give me P2 equal to P1. Very easily we understood what is the That is, what is the meaning? That is, if no external force if no external force is applied, the initial momentum is equal to the final momentum. This is what we wanted to prove. We wanted to prove whenever there is no force, then momentum will remain same. That will be conserved. Okay. Now let us illustrate this point by example of considering two spherical poles. This is a situation very simple. This one, only one thing was there, and for one thing we used. Now this should be two, even if there are two things. Okay, that is the last part, little bit longer also, that we will try to do in another video after. Thank you.